Find the missing number. Blank plus 5 equals 28.
Welcome back. In today's math quest, we have a mystery to solve. Detective Mia is here to help us uncover the missing number in an addition problem. We have lots of addition strategies we can use to solve this problem. Grab your detective hats and let's get started. Do you remember when we learned about fact families? A fact family is a set of 3 related numbers. With these 3 numbers, we can create 2 addition problems and 2 subtraction problems. Now look closely at these 2 addition facts from the fact family. Do you notice anything interesting? That's right. They use the same numbers, just in a different order. Remember, when you see this pencil on screen, that tells you it's time to follow along and write in your guided notes. This is the first thing you'll want to write down today. We call these addition facts turnaround facts because we can turn that fact around or switch the add-ins, but the answer, or the sum, stays the same. Did you know this is true for all addition problems? Here's another example. If we know that 6 plus 4 equals 10, then we know that 4 plus 6 equals 10 too. No matter how big or small the numbers are, this will work. 45 plus 32 equals 77. So 32 plus 45 equals 77. Pretty cool, right? Oh, excellent question, Mia. Do you think this works with subtraction too? Let's try it. 7 minus 3 equals 4. So does 3 minus 7 equal 4? No. If Mia starts with 3 magnifying glasses, she doesn't have enough to take away 7. There's a special name for this rule. It's called the commutative property of addition, which is just like turnaround facts. As we just saw, it doesn't work with subtraction. Thanks for pointing that out, Mia. Do you think the commutative property of addition could help us with our math quest? Let's take a look back at the question. Blank plus 5 equals 28. Once we find this number, we could use the commutative property of addition. Our mystery number plus 5 equals 28, so 5 plus our mystery number will also equal 28. Since we don't know that number yet, this isn't much help. But wait, I think subtraction might help. Take a look at these 2 subtraction problems in this fact family. What do you notice? Yes, they both start with the same number and it's the largest of the 3 numbers. Addition and subtraction are inverse operations, or opposites. When you add numbers together, you get a bigger number, and when you subtract, you take some away to make a smaller number. Think of it like building and taking apart a tower of blocks. If you stack 5 blocks and then add 7 more, you have 12 blocks. But if you start at 12 and take 7 blocks away, you're back to 5. Fact families show you how addition and subtraction are always connected. So if we know that 5 plus 7 equals 12, we also know that 12 minus 7 equals 5. Let's take a look at another example. Here I use the commutative property to write 2 turnaround addition facts. 9 plus 7 equals 16, and 7 plus 9 equals 16. The inverse of addition is subtraction, so we can take our largest number, or the sum, 16, and place that first in our number sentence. Then we can subtract 7 to get 9. We can also take our sum, 16, and subtract 9 to get 7. Just like that, we have a fact family. Since addition and subtraction are inverse operations, you can rewrite a subtraction problem as an addition problem the same way. The inverse of 19 minus 4 equals 15 would start with the sum 15. Instead of subtracting, we will add. Can you finish the rest of the problem? You've got it. 15 plus 4 equals 19. See how that works? It's like we pressed the rewind button on the problem. By switching the operation and starting from the answer, we end up right back where we started. That's the magic of inverse operations. They undo each other. So, we've realized that the commutative property of addition won't help us solve our math quest. But what about inverse operations? Let's take a look. Can we turn this into a subtraction problem to help us solve? Yes. Instead of ending with the sum of 28, let's start with it. What will we subtract or take away? Right, we will subtract 5. We can quickly line this up by place value to subtract like we did in our last math quest. What's our answer? In our ones place, 8 minus 5 equals 3. There's nothing to subtract from the tens place, so we will just bring it down and it will stay the same. Our answer is 23. Are we done? Oh, Mia's right. Now we need to try adding 23 where we had a missing number in the math quest to double check our work. 23 plus 5 equals 28. Is this correct? Let's count on from 23 5 times. 24, 25, 26, 27, 28. It worked! Now that we've also learned the commutative property, we know that we could switch these two numbers and get the same answer either way. Great work! Write our final answer on your math quest while I input our answer. We solved the mystery. Thanks for your help, Mia. Today we learned how the commutative property and inverse operations can help us find missing numbers in addition and subtraction problems. Remember, every problem has a solution, and we've got the skills to solve it. See you next time.